Solve by writing in the following form. B to the k equals a, and remember that log base b of a equals k. And we have several examples. So we're dealing with logarithms, agreed? Let's realize that in logarithms, we have what we call the base, and it exists both in the log form and in the exponential form. Since we're using back and forth the log and the exponential form to solve between equations or for equations. So the base is that b there in the exponent and that b there in the log format. Notice in the log format you write it as a subscript, meaning you write it small and down a little bit lower, as you've seen in that example there. So let's also realize that the a value and where it's located at for this case, it's either on the other side of their equal sign for when it's in exponential form, or it's in the parentheses when it's in log format. That's where the a is. Keep that in mind. And likewise, let's keep in mind where the exponent is for the exponential format and where the k value is, since they're technically the same numbers when you're converting back and forth. So do realize where your k is for the exponent in the exponential format, in the logarithmic format. It's on the other side of the equal sign, okay? This will make it a lot easier to simplify and or solve. So once again, let's rewrite it. Whenever you're working on homework problems, I recommend you write them at the top of your page. Basically your equations at the top of your page. So there's the first equation, log base v of a equals k. And its equivalent, b to the k equals a. And let's realize that you can go from log base b of a equals k and convert it into b to the k equals a. So from logarithmic to exponential. And likewise, you can actually go in reverse order as well. You can go from exponential, b to the k equals a, and convert it into a log format of base b of a equals k. So once again, they're reversible. You can work back and forth between them. Be aware of that. It'll make your life a lot easier. So let's try the first example. First example asks us to do log base 7 of 49. And how do we do that once again? Well, how about we try converting? One suggestion. Can we convert it? Let's see, let's use the equation from the top of our page and let's just copy it down. Once again, copying down our formula from the top of our page. There we go. And this is the only time I'm going to show you that I'm copying it from the top of our page, but otherwise, every single time I'm just looking at the top and copying it down to make it easier. Okay, so converting from log into exponential. Let's realize that we have the 49 is basically what's in parentheses, agreed? That is our a value in the log format. In the exponential, it's the a value on the other side of the equal sign. 49. Okay, and how about the v value? The v value is the 7, it's our base, right? So there it is, it's 7 to the k equals 49. And now the question is, how many times do I multiply 7 to get 49? 7 times 7, hey, there it is, 49. You're multiplying it twice. So if you multiply 7 times 7, it gives you 49. This would be where a calculator might be really useful if you want to double check. So a real quick double check. 7 times 7 gives us 49. Or to write it in the form that we have it in exponential form, 7, then push the caret key right below your clear button, caret key, and put a 2. So that's, you're telling your calculator to take 7 and put it to the power of 2. Remember, TI-84 is the only difference is it shows it as an exponent, slightly higher, and that's about it. The TI-84s look somewhat similar, except they don't show the caret key. They just raise it up a little bit. So there you go, 7 to the power of 2 is 49. We verified that it worked in our calculator as well. So there's our answer then. It's 2. Log base 7 of 49 equals 2. Let's try example number 2. Log base 8 is what they have under. Yep. Log base 8 of 64. So once again, how do we do this again? Hey, at the top of our page, right? Bring down your formula. Well, in this case, let's realize that the v value is 8 and the a value is 64. So we're essentially just writing them on the opposite side of the equal sign. 64 goes on the right side, the base v goes on the left side, and our exponent is k. Agreed? So how many times do I multiply 8 to get 64? If you've forgotten your multiplications, I highly recommend that you practice them. Otherwise, let's double check your answer, what you stated. 8 times 8, well, that gives us 64. Or we can go 8 squared, right? So in other words, once again, it's twice. We multiply the 8 2 times, hence our k value is 2. So therefore, log base 8 of 64, our answer is 2. And there's our answer. Let's try the next one. 3. Log base 3 of 81. Let's try converting once again. At conversion, 3 equals 81. So base 3 should give us 81. In other words, how many times do we multiply 3 until we get 81? Once again, we could try multiplying, right? So try multiplying. 3 times 3 gives us 9 times another 3. Yep, may have gone with the wrong value. Yep. 3 times 3 gives us 9 times 3 gives us 27 times 3 gives us 81. Hey, how many times was that? 4 times, you say? So let's try it out. 3 to the 4, 3 caret key 4 will give us 81. Definitely. So let's write our answer then. 3 to the 4 gives us 81, and likewise, log base 3 of 81 equals 4. There must be an easier way to do this, right? Okay, let's realize another way we could actually try this out is by graphing it. Go to y equals, and let's say you have 3 to the k, or in other words, 3 caret key. Right below your clear button is your caret key. If we want to write x, your calculator doesn't know k, so we want to write x. So we want to graph it, and I'll just do a quick visual of the graph. If you don't see anything that looks like this, go to zoom and do a zoom standard. But it really doesn't matter what it looks like on our graph. What we're caring about for the meanwhile is if we go to the table. So press second, and the button graph will give you a table. Second graph gives you a table. Yours may look like what I have. Maybe, maybe not. If not, you can always move up and down on this x values. That way you can see more or less depending on where you want to go. So 3 to the 4, if we multiply 3 4 times, it gives us 81. Hey, there it is. 3 to the 4 equals 81. So basically 81 will give us an x value of 3, or an exponent of, 4. So another way to do this. So let's go for the next one then. 4 log of base 5 of 125, I should say. How many times do you multiply the 5 to get 125? In other words, right? Short version for what we're doing. So 5 equals 125. How many times do you multiply by 5? That's our exponent, agree? So converting back into exponential format. And we can probably try graphing this one real quick as well. So go to the y equals, instead of 3, in this case we have a 5. So let me rewrite that with a 5 there. There we go, 5. And I'll go second. Trace gives me the option of the table. Second graph gives me the option of the table. Second, and then the button graph at the very top right. Okay, so we're looking for 125. Where do I see 125? There's 5, 25, 125. Yep, there we go. It's 3. So I multiply 5 by 3 times, or 5 times 5 times 5 to get 125. So there is our answer then. 3 times. So therefore, 3 would be our answer in this case. Let's go for the next one. Number 5, log base 4 of 64. How many times do we multiply the 4 to get 64? There we go. 4 to the k equals 64. How many times? 4 times 4, 16. 16 times 4, 32. 32 times 4, you get the drift, right? Or we can try real quick on a calculator as well. Once again, we've learned our technique, so let's use it. So instead of 5, I'm using a 4, so 4 to the power of x. So 4 caret key x. And then go ahead and do your table by going second graph. Gives you your table. And we're looking for 64 on the y values. There's 4, 16, and 64 is 3 times. So if we multiply the 4 3 times, so 4 times 4 times 4 will give us 64. So once again, our answer is 3. So log base 4 of 64 is 3. We multiply the base, in other words the 4, 3 times. Okay, and last but not least, we have log base 10 of, let's see, 100,000. Huh. Log base 10 of 100,000. How do we do that one again? Well, just similar to before. We want to convert it, right? 10. How many times do we multiply the 10 until we get 100,000? This one's fairly easy though. Just count the zeros. The number of zeros you have is the exponent value. So how many zeros do we have? 1, 2, 3, 4, 5 zeros is what we have on there. So therefore our exponent becomes 5, so our answer becomes 5. Agreed? Well, this one's a little bit easier. Well, we can try graphing it as well. So we can go to y equals, instead of 4 we have 10. So 10 caret key x. And then go to second. Graph will give us the option of table. And we're looking for 100,000, right? So there's 10, 100, 1,000, 10,000, and finally 100,000 would give us 5. Notice, unfortunately, from there on it gives us an exponential format because it runs out of space. 1 e to the 6, 1 e to the 7, 1 e to the 8, so that's going to make it tricky if you have any bigger numbers, right? So be aware of that, unfortunately. And let me go ahead and clear this out. Well, it looks like I can't clear out. So second mode, the mode button is right next to the second button. Second mode will get you out of that screen. And let's clear this out. So another way we can do this is, since this is a base 10, be aware. Your calculator has a base 10 button on your calculator. Kind of tricky, huh? Calculator on calculator. Okay, so if you push the log button, your log button is right next to your number 7 keypad on the left side. So take a look at the log button. Press the log button. You should get something that looks like this. Log button. And it's base 10. It won't tell you that it's base 10. It's assumed that it's base 10 because it's on there already. So you have a base 10. Another way that you have is base ln, natural log, right below it. We'll talk about that in different videos, but be aware of that. That button exists, and it's just like saying the base of e in this case, and it's a number, which we'll talk about in the future as well. But for now, let's just stick to the log base 10. Log base 10 of 100,000. So we're going to put 1 and 1, 2, 3, 4, 5 zeros to represent 100,000. Agreed? Close your parentheses. I highly recommend you always get in the habit of closing your parentheses. That way you can see where your parentheses began and where it ends. Agreed? So now hit enter. And it gives you the value of 5. So pretty straightforward. Agreed? It essentially tells you the exponent. There's your exponent. It's 5. Alright, so now that we got the answer, we got a few techniques of how to solve it. Agreed? So I highly recommend you practice them.